All right, welcome everyone to Redesign, Repurpose, Reskin, Renovate. The learning objectives for this session are shown on the screen, and we will be following up with a survey to collect more information on so that you can all receive credit from the American Institute of Architects if you'd like to after the event. We will also collect questions submitted to the Q&A box throughout the session. And if our speaker isn't able to get to all of your questions, he will answer them in writing and we will share them on the website after the teach-in. My name is Erin McDade. I'm with Architecture 2030, and I will be moderating the session today. And it is my pleasure to introduce our speaker for this session, Carl Elefante. Carl is a former AIA president and principal emeritus with Quinn Evans Architecture. Carl, take it away.
Well, thank you, Erin, and hello again, everyone. It's very good to be here, having an opportunity to really do the reset, get ourselves on the right foot with the next generation of climate action. I'm going to go ahead and share my screen, and let's see how that will do. And we'll get all the technology going. And Erin, looking good?
Looks great. Go for it.
Great. Okay. Well, again, it's great being here, and we're doing important work today. I wanted to begin with just telling you a little bit about myself. And that is to just say that I've spent most of my architectural career working with existing buildings. I like to think of that as really having spent this time on sustainable stewardship. It's been a great privilege to have the opportunity to work with just fabulous buildings, just absolutely iconic, gorgeous buildings that we're so fortunate to have the opportunity to literally be the stewards of these buildings and continue their life for another generation. And, part of it is their cultural and heritage value, but part of it is also very much their material value and really looking at them as resources that are worth preserving and investments that are worth continuing. I also want to confess to very much being sort of a child of the 60s, and it seems very relevant today, especially in 2020. There's so much about this year that makes me think of my formative years when I was just starting architecture school in the late 60s. It was a time of just incredible promise and amazing human accomplishment. For people of my generation, that first time that humans stepped on the moon was just hard to describe. How incredible the accomplishments of humanity seemed to us. At the same time, it was an era of just frustrating troubles, and the COVID pandemic situation that we've been faced with this year just really kind of resonates with me about how familiar it feels in both the fortunate and unfortunate ways. And another dimension of it that I wanted to mention, and it's been again, something that was an important part of my life, but I feel like it's so relevant to where we are today in 2020. When I was truly a preteen and Kennedy became president of the United States, his inaugural address is one that you oftentimes hear quoted. And there's that famous line, "Ask not what your country can do for you, but what you can do for your country." And that was really part of his speech, kind of the crescendo of his speech, where what he talked about was the world that he faced as an incoming president, the world that his generation faced, and the challenges that were thrust upon them by history, thrust upon them by destiny, really. And that world was, as he described it, an hour of maximum danger. And his reaction to it as a leader is something that has lasted with me my entire life. And I think it's very relevant to today. He embraced those challenges. And of course, the challenges that he was faced with was that the atomic weapons that had ended the Second World War had metastasized into these huge arsenals of weapons of mass destruction. And literally, the arms race that he faced as president was a truly existential threat to his generation. And that was such a tangible thing to see. There were mushroom clouds and so on. And we today are faced with an existential threat, and that is climate change. And it's much harder to see. Buildings don't all have smokestacks belching out black trails of fumes. It's everything we do. It's how our industry works. It's how our buildings work. It's how our transportation work. And yet, taken together, it creates this hour of maximum danger that now we, our generation, are faced with. It's our challenge to embrace. As Kennedy turned the arms race into the space race and turned it into a challenge for human potential rather than a threat for human existence, we're faced with that same challenge with climate action. It's time for us to turn this into the space race. So here we are, the Paris Agreement, it's almost 5 years ago now, and it's defined our reality. And, the notion of having goals that we were challenged to meet by 2050, that it literally was going to require global cooperation. Everyone would have to work together to meet these goals and to really be ambitious about doing that. And we understand it in the building sector. And of course, Ed Mazaria, who is our fearless leader with pulling together this incredible teach-in, he was one of the key people that went to Paris and talked about the importance of the building sector and its influence on both the problems of climate change, the causes of climate change, and the needed actions to resolve climate action. And we all now know these dire statistics about just how much the building sector really is responsible for greenhouse gas emissions. And it's our challenge. This is what we in this industry and we in this generation of architects and planners and the people that shape the built environment. This is our challenge. This is our hour of maximum danger. This is our arms race that we have to turn into the space race. And we know what to do. We know how to solve this problem. It doesn't require an invention of some magic unicorn to solve this problem. We need to be completely dependent on renewable energy. We retooled once, we can retool again. It's hard to remember that John D. Rockefeller was a very, very, very wealthy man before the automobile ever needed a gallon of gasoline. The petroleum industry was built on kerosene for lamps and heating, and it transformed itself when electricity came along and was no longer needed for those things into the fuels for our automobiles. And it's time for us to transition again to renewable energy. We've done it before, it's time to do it now. Time to do it quickly. We need to operate our buildings with renewable energy without carbon, just like we need to operate our vehicles. And then also we need to eliminate the embodied carbon. So we know what to do, we know how to do it. But we also know from this reset and from other things that have led to this reset that it's really time for us to be more ambitious with our goals. So we know what the hour of maximum danger is, and we know what we need to do about it. And we know that we in the building sector, in those who shape the built environment, we have a very, very big role to play in getting to climate solutions. And I would like to talk about the importance of sustainable stewardship as a perspective to really understand how we can contribute by addressing the existing building stock. And I just want to spend another minute on really why I use this terminology about sustainable stewardship and what this means. I'm just showing you here an example from project work of mine and others at Quinn Evans. This is the National Academy of Sciences buildings here in Washington, D.C. It's an absolutely gorgeous historic building. The arts and crafts that are integrated into this building, it's just a magnificent building. Bertram Goodhue was the original architect on it. And Quinn Evans, we're literally the third generation of architects to get to be the stewards of this remarkable building. And, we got to add our own bits to it. And this is a photograph of one of the courtyards that we created in the kind of unused interstitial spaces of this rather Beaux-Arts floor plan. And what did we do? Well, we made the space usable, but we capped the courtyards with skylights, which, by the way, allowed us to upgrade the thermal envelope of the building without touching the wall surfaces. They're not exterior walls anymore. They're interior walls. They don't need more insulation. The insulation is provided by the creation of the atrium. Very efficient way. We reduced the thermal envelope of the building by almost 25% just by capping these courtyards. But then we also integrated photovoltaics into the skylight. And even though this is a tiny percentage of the building power that is represented by this PV array, this is the building where the client scientists of the United States meet to talk about climate change and climate action. So here is this gorgeous historic building where over the last 10 years, the major science conferences in the US, those scientists were able to walk into this courtyard and see that even a gorgeous historic building like this actually contributes to climate action. It is part of the climate solution. So let's dig into carbon in buildings and really what we need to understand about it and really, how can we change our behavior to address this hour of maximum danger and turn this arms race into the space race. First and foremost, we recognize that we have really two parts of the carbon equation to solve, the operational carbon and the embodied carbon. And with conventional construction techniques and also conventional building performance, it's somewhat of a truism to say that the embodied carbon of a building is about equal to the operational carbon over something like a 20 or 30 year period. Obviously, I'm using an average here, but the embodied carbon and the operational carbon are both significant. What we also understand is that there's a time scale, there's a time frame when we look at carbon in buildings. And with the operational carbon, it's obvious that every year, every 10 years, every 20 years, we're continuing to generate greenhouse gases. And if a building is inefficient, it actually generates pretty quickly. And as we make more efficient buildings, it generates greenhouse gases more slowly, but it continues over time, and it continues and it continues. Really, that efficiency is a gift that keeps on giving. And what it means over time is hugely important. And you can see here that with a building that meets the efficiency levels that we think today are minimum code levels that are essentially 75% more efficient than conventional, that what you consume in 100 years is basically equivalent to what you would have consumed in 25 years. So the time frame is enormously important. Well, that's true with embodied carbon as well. And we tend to not think about embodied carbon in terms of its timeline. It's just this one-time thing. There it is, we built the building, that's the embodied carbon. But that's actually not true. Buildings are complex systems made out of many different components, and some of them age very quickly and really need work and reinvestment of carbon on a very routine basis. Some of them in a kind of a medium time horizon where it might be 20 or 30 or even 50 years. And then some of them are literally one-time investment. For example, the basic structure of a building, it's going to be there for the life of the building. It doesn't really require a lot of reinvestment. But again, over that same 100-year life, there really is a life cycle of embodied carbon as well. So we need to think about embodied carbon as a time frame issue, as a life cycle design issue as well. And I want to define this a little bit more with a little bit of the numbers side of it to get a sense of the scale of what we're talking about here. And I'll start with a kind of a somewhat of a paraphrasing of something you may have seen Ed Mazzaria talk about. The modern-era city is just an incredible invention of the post-World War II era, and that we've transformed the face of the earth with literally hundreds of cities. You know, there are more than 500 cities with a million residents, and there are over 50 cities with more than 5 million residents in the world. So the world has been transformed since 1945 with this incredible explosion of building. It's everywhere. There's hardly a building that you can see in one of these photographs. These are the 4 largest cities in the United States, only one of which is world-class large, and that's New York. The others are little towns by comparison on a world scale. But there's hardly a building in these photos that was built the year I was born. The other thing I wanted to talk about is just really, well, what does this growth over time mean in terms of what the building stock characteristics are? This is the United States Commercial Building Energy Survey, which is kept by the federal government, of what the energy performance is of commercial buildings. Excuse me. What you can see here with the orange bars is that those are sort of the traditional buildings, like that National Academy of Sciences. Those are pre-World War II buildings. They're a very small fraction. It's actually only a little over 10% of the current building stock is that era of buildings. The blue bars are the modern era buildings, those skyscrapers that were in those photographs of New York, Chicago, LA, and Houston. They are literally 2/3 of the existing building stock in the United States of America. And they're very different buildings. Those modern era buildings are fundamentally different from the 19th century buildings and the traditional buildings from eras before. In the first place, they were absolutely made addicted to fossil fuels. If you unplug them, the windows don't open, the mechanical systems don't work, the elevators don't work, they become uninhabitable without consuming energy. That's a very different paradigm from buildings that were built to be able to open the windows and have ventilation and lighting, given to you by the sun and the wind. And in fact, there's a fair body of literature that's really developed talking about just what a bad paradigm, what a bad design idea so many of these modern era buildings were built to. They're quite difficult buildings. They're a challenge to deal with. As a sustainable steward, as myself, they're challenging. One of the reasons why I think it's important to talk about this now is that some of these very, very large scale buildings are beginning to be taken down. And the idea of taking a 50 or 60 or 70 story building and throwing it in the garbage, putting it in the landfill is just, I think it's criminal behavior. It's urban vandalism on a scale that's almost unimaginable. And 270 Park Avenue, which is a building that is being demolished as we speak in New York City, is perhaps the poster child of this. And by the way, it's one of the great achievements of Natalie Dubois, who was the only female design partner at Skidmore, Owings and Merrill from the mid-century modern era. So what can we do with this generation of buildings? Here in the US and in many places around the world, it is the major challenge that we're faced with getting rid of the existing footprint. The existing footprint of greenhouse gas emissions is coming from existing buildings. We have to work with them. We have to do something about them. We have to do something with all of them. That's where the current footprint is coming from. So this is a kind of a Washington, D.C. example. You know, D.C. has very few buildings that are taller than 10 or 12 stories because of height limits that go back a couple hundred years. But on the left, you see a pretty typical mid-80s building with a concrete frame and precast concrete walls and ribbon windows and so on, which the renovation technique that is being used throughout the city is basically take everything off the outside, take everything out of the inside, and really just keep the concrete frame, and then rebuild the whole outside, rebuild the whole inside, and repurpose it to whatever it is that you need the building to do. Now, that may seem like an awful lot of work that's being thrown out and not very much work that's being kept. But let's dig into that a little bit. I'm going to show you an example of a project that we did in Detroit. And this was to take a building that was a kind of typical mid-century tower and repurpose it from an abandoned office building and really turn it into housing. So just like the buildings we saw from Washington, what we did basically was to keep the structure. Doesn't sound like much, but we kept the floor plates and the building frame. We reskinned the building in its entirety. And then we completely gutted the inside, new partitioning to make apartments, put kitchens in, put bathrooms in to make it apartments, not office space, new mechanical systems, plumbing systems, etc. It's like a new building, except that we kept the structure. So what does that matter? Well, when you start to look at the embodied carbon and compare it to what you get as a result with the operational carbon improvements, the operational carbon improvements are very real. They're very important. They are the gift that keeps on giving. But the reskinning was only about a quarter, not, somewhere between a quarter and a third of the actual embodied carbon investment that we had to make. Most of it was to redo the interiors of the building, okay? But by keeping the structure of the building, we avoided doubling again the amount of embodied carbon investment that would have been required if we had simply torn the building down and replaced it. And I want to say another thing about time. The carbon payback for this building with the operational efficiencies that we've built into it, the carbon payback, with the reskinned, rebuilt, housing converted building is in 6.5 years. If we had replaced the structure as well, the payback would have been more than 20 years. So between now and 2040, that's the whole time frame. So it's important. It's important work to get done. And I also just want to end this by saying that this reskinning and really repurposing buildings, there's a lot of interesting work that's being done. And here are 3 examples. Lever House, which is another one of the same era as the 270 Park Avenue buildings by Skidmore. This is a building that was considered to be historically significant. It was the first of these types, completed in 1952. What you see here is a completely reskinned building, even though it looks exactly the way it looked before. You see no pre-existing material in this photo. It's all new. The one in the middle, the Celebrezzi building in Cleveland, Ohio, it's a building that was kind of that ilk, of that era, but literally what the project did in the reworking of this building was to overclad that existing facade, essentially keeping it in place and overcladding it with another layer of glass. So it's literally a double facade building. much, much, much better performance. And then on the left is the Wyatt Green building in Portland, Oregon. The before picture of this looked almost exactly the same as the Celebrezzi building, but like the buildings that I showed in Washington and the one in Detroit, it's completely reskinned. And here it's reskinned to have facades that respond to their solar orientation. So we're seeing the west facade here, which has a brise soleil to really keep the sun out and to make it so that it's respecting the solar load of the west facade. So what does this look like as a design paradigm? How do we design to redesign intelligently with this whole era of modern era buildings that we have to deal with? And I want to go back to just emphasize that buildings are complex. They have multiple layers. They're like an onion with multiple layers of what makes them. Each of those layers has a different performance profile to them. Each of those layers has a different life expectancy, service life expectancy to it. We need to design that into what we're doing. Fortunately, we have the protocols, we have the descriptions of what counts and how it counts and why it counts. We also have the tools that are literally integrated into the design tools that we use to design and document buildings and to do all the calculations and so on, to engineer them. Those tools now have integratable life cycle analysis tools for us to really get to the bottom line, to get to the numbers. There are many tools. There are some that are really to be used very early on, big picture thinking, all the way down to the tools that will let us measure the difference between one design choice and the other. So we really have the equipment that we need. And I just want to kind of end this part of it by saying, you have to sweat the details. You have to do the work. And this is just an example of concrete. On the left is what is concrete made out of. And you can see the gray is, a relatively small percentage, on average about 13% of concrete is the cement. Okay, most of it's sand and aggregate. Okay, well, on the right, you can see that the emissions, more than 3/4 of the emissions come from the cement. So designing to cement content is extremely important with concrete. Another thing I'm just going to mention here is that concrete has an enormous potential as a carbon sequestration material as well. So I just want to drive this home a little bit more in terms of really changing our attitude, having a stewardship attitude about the building stock. And really, it's a philosophy, it's a movement. The environmental movement began when people like Rachel Carson made us aware that human beings were changing the natural environment, intended or not. And of course, most of it was not intended, and most of it was consequences that we were ignorant of. Well, we can't be ignorant of them anymore. And climate change is right at the top of the list. We know what the consequences are. Well, saving buildings was a parallel movement that was happening at the same period of time, where there was a question, are we throwing out things that are more valuable than what we're replacing them with? And with the modern era building stock, that's a very important question to ask and to answer. This is another building that we did in Detroit, 71 Garfield Street. Really, Carl, you really want me to love a building like this and think it's valuable and take care of it? Yes, I do. Even buildings with trees growing up where the roof used to be, even buildings with no windows in them anymore. This building was able to be converted back into viable living spaces. It actually has a story from the Harlem Renaissance era of Detroit. This was a significant building in the creation of the African-American community in Detroit back more than 100 years ago. And we were also able to green the building. It has a solar array that covers the whole roof. It has ground source heat pumps. It doesn't even have land for the ground source heat pump well. We borrowed it from the public space. We literally got permission to use public space for a well field. And this on a building that had no roof and no floors and no windows. There's no reason why you can't do it on your next project too. And this point was made by a couple of the speakers earlier today, and particularly what Mr. Yu was saying about his work, kind of the low tech, high tech, it's time for, we look at technology for the solution to everything. And our definition of what a green building looks like today tends to be very, very heavily dependent on technology. And in centuries past, the technology was much lower tech, but that doesn't mean it was less intelligent. And in fact, I would even argue perhaps it was more intelligent. And the idea that you were connected to your surroundings, not that there was a machine connecting it for you, but that you were thinking about, are you hot, are you cold? Do you need more fresh air? Open a window, close a window, put on a sweater. This is a building in Washington, D.C., the Pension Building, designed by one of the key designers of the Capitol building, Montgomery Meigs, who was a cast iron engineer on the Capitol Dome. But it's got this built-in climate system of just simply opening higher windows and creating stratified air and creating its own wind, creating its own breeze. And I just want to continue this to say that if you look at Ed Mazaria's early work, what really led to his whole passive, solar design handbook and so on, similarly, it was using the natural systems that were available rather than thinking that there needed to be a technological system for everything. Systems avoidance was a big part of what Ed's work meant in his solar generation of modern architecture. And I just want to kind of end this with a little more contextualizing. And that is to say that we're certainly at the era of climate crisis and urgent climate action, but it's also taking place as the Earth is becoming the hot, flat, crowded world that Tom Friedman talked about so eloquently in his books. And it's the world of the Sustainable Development Goals and the New Urban Agenda. The world is urbanizing, and it's happening globally, and it's happening very quickly. And so about 6 months before Paris, this conference, the Sustainable Development Summit, took place in New York. And the United Nations proposed and adopted these 17 Sustainable Development Goals, which we've heard referred to a couple of times today. And then about 6 months after Paris was the Habitat 3 Summit in Quito, Ecuador, at which the New Urban Agenda was issued. And if you take these three UN events that happened within about a year of each other, so, Sustainability Summit, Paris Climate Accord Summit, and the Habitat Summit, and you put them together, it is literally a program for the 21st century. What does the 21st century built environment need to be doing to be part of this urban solution and climate solution? And it really is asking us to think about buildings differently, to understand them as positive, regenerative helpers to these many, many problems that we're faced with, these intransigent problems that we're faced with today. Buildings can generate green power, buildings can sequester carbon, and so on. It is part of the very basic, very simple paradigm, I think said better by Winston Churchill than anyone else I've ever heard say it. First we shape our buildings, thereafter they shape us. We are now being asked to shape the built environment for the 21st century urban climate action world, decarbonized world. To decarbonize the built environment, we need to tweak everything. We need to modify everything about how we build buildings, how we operate buildings, how we design buildings, how we plan cities. So we have to do everything about them differently, decarbonize it. Well, everything, everywhere also means everyone. So that's our charge. We need to make the world a better place by decarbonizing it and making it ready for the urban century that's upon us. And that's us taking the Kennedy model, the Kennedy example of embracing this hour of maximum danger, taking the arms race and turning it into the space race, and doing as Kennedy did with courage and ambition and excitement, really embracing that, welcoming that, and recognizing that this is what destiny and history is asking our generation to do. So let's get busy. And with that, Erin, I'm going to stop sharing my screen.
Thank you, Carl. That was fantastic. There are questions, and I have a lot of questions. We don't have, the time to discuss them all. So as a reminder, again, we will post answers. But I want to start with one, and I don't want you to take the whole time because then I have a second one. So I'm always captivated by the part where you're talking about all of the work that goes into redoing a building, renovating and redesigning it, when you're only saving the structure, and then you go to the slide and you show what the carbon impacts of that are, and it's like, oh, of course. So my question is, when you're doing that kind of design, how are you thinking about the facade design and the interior design so that in 50 or 80 years, the architects aren't going through the same process that you went through and tearing everything down?
Yeah, so it's a great question. There's just on the project level, it's kind of like what we were talking with Paul and Jeremy. There's kind of a project level and there's a systems level. On the project level, it's literally having a building that's put together so you can take it apart and fix what needs to be fixed and put it back together again. That's one of the big technology differences between modern era, low maintenance. Whenever I hear somebody says, oh, maintenance free, that means you can't fix it. Okay.
Right.
And then on a systemic level, it's literally thinking about designing buildings that are renewable. Okay. And again, we need to do that. Let's go to your next question.
Okay, awesome. So you talked a lot about the technical aspects of this kind of thinking and this kind of design, and even in that last answer, a lot about the technical aspects, but I'm fascinated by the cultural implications and the social implications of a lot of the work you're doing. And I mean, there's the one slide where you're like, you're telling me to value this building where there's trees growing out of the roof and the windows are blown out, really? Can you talk a little bit more about what the, cascading co-benefits of this sort of work are?
So buildings are unique in that they do last for such a long period of time. But not only do they last, you actually get to experience them. So yeah, you can go to a museum and you can look at a painting that was done 500 years ago and you can experience it. But you can live in a building that was built 500 years ago and you can live in a modern way, So we get to experience buildings generation after generation after generation. So that is richer than if everything just got torn down every 50 years and replaced with something new. Okay. Think of how much of our culture is built on that, the legacy of buildings, not just for dozens of years or even hundreds of years, okay, even thousands of years. What would we understand about human culture without the pyramids? What would we understand about human culture without these icons? But then in our cities, it's much more incremental. It's, what's the most adapted neighborhood in New York City? It's Soho. What was it? It was these crummy old barn building warehouses that were just timber frames and timber floors with brick or iron facades, but they were so flexible, so reusable, and also they had that character. They had that, and you know, the truism is whatever our parents built is junk, and whatever our grandparents built was the most amazing thing that ever happened. And so there is sort of this wheel of time that we just, you know, sort of don't even pay attention to, but is this sort of representation of how much the cultural importance of buildings kind of builds over time.
Yeah, and so then that strikes me what you said. Part of the reason that those buildings were saved is because they had some character, some quality that people liked. But then also in your talk, you show these iconic buildings that people started revolutions to try to preserve and didn't end up succeeding in every case. So I mean, why? What's that about?
Well, you know, it's a big world and there's room for a lot of different things. And, you know, what matters, where does it matter, when does it matter? And so I would absolutely, I have been involved with, you know, well, let's defend this modern era building. Oh, it's, you know, my 5-year-old could design that. Well, no, you know, you know, yeah, but you know, so it's not a one size fits all. But again, I keep sort of coming back to the sustainable stewardship idea. Let's just have the attitude, you know, all of our children have value, you know, they're different. We don't expect them to all grow up to be the same, but we totally express in everything that we do that we value each of them. Well, let's take that attitude about the building stock. We have to do something with it. We can't leave it alone. It's polluting our world with greenhouse gases. We have to do something about it. But let's do it with the attitude that every one of them is valuable.
Well, and I think you've certainly demonstrated, even in this short talk you've given, and I'm sure your collective body of work even more so, that you really can do that. You really can take buildings from the whole range of obvious value to, you know, maybe you got to work a little more to uncover what that value is and really make that building shine, but you totally can do it.
You know, the Plaza building in Detroit, that tower building in Detroit, you know, 10 years ago, even if you said, oh, wouldn't it be cool to live in an old 1950s era, you know, abandoned office building in Detroit? Wouldn't that be a cool place to have an apartment in? Everybody would say you're completely crazy. No, there's no way. And here it is, you know, a decade later, and you know, it's part of the renaissance of a rebirth in Detroit.
Which then speaks back to the beyond the carbon and the technical element of this, right? I mean, that's work like that is helping to revitalize entire neighborhoods and economies, and that has value beyond anything that we can look at from a cost and carbon perspective.
Yeah. Hey, the artists started moving to Soho because it was the cheap rent district 40 years ago.
All right. Well, we do have to end there, but again, thank you so much, Carl, for a really fantastic and compelling session, and thanks for everyone who joined. As a reminder, we do have a second set of sessions starting in the next, really the next minute. So I encourage everyone to go back to the agenda and find your next session. Thanks, Carl.
And good to see you, Erin.